The universe, vast and seemingly infinite, had a beginning, but does it also have an end? Scientists have been studying the cosmos for decades, trying to understand what will ultimately happen to everything we know. Will the universe expand forever, collapse upon itself, or be torn apart? In this video, we'll explore the leading theories on the ultimate fate of the universe. One of the most widely accepted theories is called the Big Freeze, also known as the heat death of the universe. Right now, the universe is expanding. Galaxies are moving away from each other like raisins in a rising loaf of bread. But this expansion isn't slowing down, it's accelerating. If this expansion continues indefinitely, the universe will become a very different place. Galaxies will drift so far apart they'll be isolated islands in the vast cosmic ocean. Stars will burn through their fuel and die out, one by one. Eventually the universe will run out of hydrogen to fuel new stars, and the cosmic lights will start to go out. Without the warmth of stars, space will grow colder and colder, approaching absolute zero. In the end, according to the Big Freeze scenario, the universe will be a sea of nothingness, a cold, dark, and utterly uniform expanse. Scientists have developed ingenious ways to measure the universe's expansion, using exploding stars called supernovae as cosmic mile markers. But what if the universe isn't destined for a slow fade to black? What if, instead of expanding forever, it eventually reverses course? This is the idea behind the Big Crunch, a scenario where gravity stages a comeback. Imagine that instead of expanding endlessly, the universe has a kind of cosmic rubber band effect. The expansion slows down, eventually coming to a halt. Then, like a ball thrown upwards that loses its momentum and falls back down, the universe begins to contract. Galaxies, once racing away from each other, would begin to draw closer. At first, this contraction might be slow and almost imperceptible, but as gravity tightened its grip, the pace would quicken. Everything we see around us, all the matter and energy in the universe, would converge on a single point, a singularity of infinite density and temperature. Some theorists have even proposed that the Big Crunch could be followed by another Big Bang, creating a new universe from the ashes of the old one. However, recent observations have cast doubt on the Big Crunch scenario, due to the discovery of dark energy. Chapter 3. The Big Rip, the Universe Unraveling. We've explored a universe slowly freezing in the Big Freeze and a universe collapsing in on itself in the Big Crunch. But what if the end of the universe is not a whimper or a bang but a rip? This is the unsettling prospect of the Big Rip, a scenario where the very fabric of space-time is torn apart. The culprit in this cosmic unraveling is dark energy, that enigmatic force that's pushing the universe apart at an accelerating rate. In the Big Rip scenario, dark energy doesn't just continue to drive the expansion of the universe, it grows stronger over time. First, galaxies would be pulled apart, their gravity no longer strong enough to hold them together. Then, solar systems would be disrupted as the space between planets stretched at an alarming rate. Eventually, even atoms themselves would be ripped apart, their constituent particles scattered to the cosmic winds. The very fabric of space-time would be stretched to its breaking point, ultimately tearing apart. Some physicists believe that if the Big Rip is in our future, it could happen surprisingly soon, perhaps in as little as 22 billion years. Chapter 4. The Cyclic Universe. No end, only new beginnings. We've explored scenarios where the universe ends in ice, fire, or complete disintegration. But what if the universe doesn't end at all? What if, instead of a final curtain call, there's a cosmic encore, a never-ending cycle of death and rebirth? This is the alluring idea behind the Cyclic Universe. Imagine a universe that expands, contracts, and expands again, like a cosmic lung breathing in and out. In this scenario, the Big Bang is followed by a period of expansion, much like what we observe today. But eventually this expansion slows, comes to a halt, and reverses. Gravity takes over, pulling everything back together in a big crunch. Instead of ending in a true singularity, the universe experiences a bounce. This bounce sets the stage for a new Big Bang, a burst of energy and expansion that creates a fresh universe from the remnants of the old one. While the Cyclic Universe is a captivating idea, it's important to note that it remains a theoretical concept. Chapter 5. Beyond the familiar other cosmic endgames. We've journeyed through the most widely discussed theories about the universe's fate. The Big Freeze, the Big Crunch, the Big Rip, and the Cyclic Universe. But the cosmos is full of surprises, and our current understanding may only scratch the surface of what's possible. One intriguing possibility is the vacuum decay hypothesis. Imagine our universe like a ball resting in a valley. What if there's a deeper valley, a lower energy state, that the universe could suddenly transition into? This transition, known as vacuum decay, would be triggered by a random quantum fluctuation. This bubble of a lower energy vacuum would expand at the speed of light, erasing everything in its path, including the very laws of physics as we know them. Another mind-bending possibility arises from the multiverse theory. What if our universe is just one of many, each a bubble in a vast cosmic foam? These universes could have different physical laws and constants. And then there's the simulation hypothesis. What if our reality isn't real at all, but rather a sophisticated computer simulation running on some advanced civilization's supercomputer? Outro: The universe's fate, a cosmic mystery unfolds. On-screen text: what do you think? What will be the fate of the universe? The end of the universe is one of the greatest mysteries of cosmology. Will we drift into eternal darkness, collapse in on ourselves, or be ripped apart by unseen forces? Scientists continue to search for answers, but for now, the ultimate fate of the cosmos remains unknown. What do you think? Which theory do you find most fascinating? Let us know in the comments.